Why does pinging 192.168.072, only 2 dots, return a response from 192.168.0.58? I mistakenly missed the dot off of an IP address and typed in 192.168.072. To my surprise, I connected to a machine at 192.168.0.58. If I ping 192.168.072, I get responses from 192.168.0.58. Why is this? I'm on a Windows PC on a Windows domain. If I ping 192.168.72, I get a response from 192.168.0.72, so it seems the 0 in 072, in my original mistake, is significant. This question was a super user question of the week. Read the blog entry for more details or contribute to the blog yourself.
Everybody is overcomplicating it with RFCs, IP classes, and such. Simply run a few tests to see how the ping command parses the IP input by the user, extraneous chaff removed. As you can see, the ping command in Windows allows you to use different IP address formats. An IP4 address can be broken down into 4 parts, dotted quad, as so, a .b.c.d, and the ping command allows you to leave some out, filling in a default of 0 as follows. If you only supply a single part, then if it is under 255, the maximum for an octet, it is treated like an octet as above, but if it is greater than 255, then it is converted and rolled over into the next field, i.e., mod 256. There are a few edge cases like providing more than 4 parts doesn't seem to work. For example, pinging google.com's IP won't work for either 0.74.125.226.4 or 74.125.226.4.0. You can also use hexadecimal notation in both dotted quad and flat form, but must format it by prepending 0x to each octet. So, there are plenty of ways to represent an IP4 IP address. You can use flat or dotted quad, or dotted triple, dotted double, or even dotted single format, and for each one, you can use, or even mix and match, decimal, octal, and hexadecimal. For example, you can ping google.com in the following ways. Thank goodness that binary notation support was not added. Application. In your case, pinging 192.168.072 uses the third format in the above table, a .b.0.c, so you are actually pinging 192.168.0.072. Further, because you have a leading 0 on the last part, it is treated as octal, which in decimal is 58. Mystery solved. Note that while the Windows ping command allows for such a wide variety of formats for the input and interprets non-standard formats in the ways seen, that does not necessarily mean that you can use such formats everywhere. Some programs may force you to provide all 4 parts of a dotted quad, others may not allow mixing and matching decimal and octal, and so on. Also, IPv6 addresses further complicate the parsing logic and input format acceptability. Addendum. SIS pointed out that if you use an invalid character in one of the numbers, for example, an 8 or 9 when using octal, a G in hex mode, etc., then ping is smart enough to recognize that and interpret it as a string AL. IC. URL instead of as a numeric IP address. As someone who has had numerous aneurysms and heart attacks trying to write supposedly simple code to accommodate the exponentially exploding number of permutations of data values, I appreciate that it seems to correctly process all of the input variations, in this case, at least 31 plus 32 plus 33 plus 34 equals 120 variations. So, while specifying 010.020.030.040 will ping 8.16.24.32 as expected, passing 010.020.030.080 to ping will be treated like a URL instead of an IP address, like foo.bar.baz.com, which could, but sadly does not, exist. In other words, it tries to ping the subdomain 010 on the subdomain 020 on the domain 030 at the top-level domain 080. However, since 080 is not a valid TLD, like .com, .net, and their buddies, the connection fails right at the first step. The same thing happens with 090.010.010.010 where the invalid character is in a different octet. Likewise, 0xf.0xf.0xf.0xf pings 15.15.15.15, but 0xh1.0 by 1.0xg0.0f fails. Oh well, I guess that's what you get for not being fluent in multiple number bases. It's probably easier and safer to just make sure to always use 4-dotted quad, 40q, quaddy quad, qtq addresses. So go forth and learn some number bases. You'll be able to show off it and be the life of parties, and as they say, there are 10 types of people, those who know binary and those who don't. Let's not even think about IPv6 addresses. I think they're one of the 111 seals.
In addition to Atnoi 242's important point about octal notation, an observation that IP addresses can be shortened, the other critical piece is knowing how shortened IP addresses are interpreted. One might naively guess that if some of the 4 numbers are missing, the parser would add 0 filled bytes onto the end, or the beginning, of the sequence of bytes. But this doesn't match the behavior the op reported. 192.168.072 was parsed as 192.168.0.58, not as 192.168.58.0, nor 0.192.168.58. Apparently Windows and Linux ping, the version you tried and the ones I tried, use something equivalent to a net_audn to parse the IP address argument. The man page for a net_audn says, so there you have it. 192.168.072 fits the ABC pattern, so the 072, after parsing as an octal number, was interpreted as a 16-bit value that defines the rightmost 2 bytes of the binary address, equivalent to 0.58. The above rules are equivalent to saying that if any of the 4 numbers are missing, the needed 0-filled bytes are added immediately before the last number given, not at the end nor at the beginning of the string of bytes. Expressing it this way works if the last number given is less than 256. Note that newer versions of ping may not allow this kind of shorthand, nor the octal interpretation. The 2010 source code for Aputals, including ping, that I found uses a net_10 rather than a net_10 to parse the IP address argument. The man page for a net_10 says, unlike a net_10 and a net_address3, a net_10 supports IP6 addresses. On the other hand, a net_10 only accepts IP4 addresses in dotted decimal notation, whereas a net_3 and a net_address3 allow the more general numbers in dots notation, hexadecimal and octal number formats, in formats that don't require all 4 bytes to be explicitly written.
You have to consider also that an IP can be represented by integers added together in significance to their position. Here's the cool thing. 192.100 and 68.58 will be 100, and 92.100 and 68.0.58 because 192.110101006 will also be 192.100 and 68.0.58 because 3,232,235,578 will also be 192.100 and 68.0.58 because
'If you want to support the channel, please consider subscribing.